Hey guys, welcome to my channel Number Pen. Today we have again a very interesting problem in differential calculus. So let's spend a few minutes reading through the problem. So we have a ladder 17 meters long leaning against the wall. The base of the ladder is pulled away from the wall at the rate of 5 meters per second. When the base of the ladder is 8 meters from the wall, how fast is the top of the ladder moving down the wall? At what rate the area of the triangle formed by the ladder, wall, and the floor is changing? So we have a ladder which is resting against a wall, and we see that the ladder is slowly sliding, in contact with the floor. I think it's easier to understand this if we draw a diagram. So let me pick out a triangle. Let me draw this, and let me use the highlighter here, right? So use the highlighter to. So this is the ladder. It's got a standard length of 17 meters, right? And this ladder is sliding against the floor, which means that, excuse me, let me use a different colored pen so that it becomes easier to understand. So as the ladder slides, we know that this is a right angled triangle. Let's mark these vertices: A, B, C, D, and E. Here we go. So let's call this the y axis, y, and this is x, right? So we have a right angle triangle here, so which means our x, means our x square plus plus y square equals length of the ladder, right? Which is 17 to the power 2, right? So we've been asked to find how fast is the top of the ladder moving down the wall, right? So what we've been asked to find is dy by dt, which is how quickly the top of the ladder is sliding against the wall, and we've been given the rate of change at which the base of the ladder is pulled away from the wall, right? Which is nothing but your y-axis. So we have dx by dt equals 5 meters per second. We've been asked to find what is dy by dt, right? And at a specific point when x equals 8 meters, right? So we have, let's, so when x equals 8 meters, we know what y is, right? Y is 17 square minus 8 square, which is 289 minus 64, which is 225. We're talking about pi square. and I go to my next line. Y is square root of 225, which is 15, right? Let me clear this out. So I'll take a minute to explain this once again. So you have right angle triangle here, where we know that x square plus y square is equal to the square of the length of the ladder, which is a constant, right? We've been asked to find the rate of change of the top of the ladder with respect to time at a specific point when it is a distance of 8 meters from the base of the ladder, right? So when it is at the distance of 8 meters, we have this y here at 15 meters, right? And what we do next is differentiate the equation 2y dy by dt. Differentiation of 17 square is a constant. And you know which equation I'm talking about. I'm talking about this equation, which is probably, I'll highlight this, right? And we have differentiated this equation here, right? So we know x, which is 8 meters. We know dx by dt, which is 5. And then we know y, we just calculated that. And we know what is dy by dt now from this equation, right? So dy by dt equals 8 into 5 is 40, and we do minus 40 divided by 15, right? Which is further factorable, which is minus 8 by 3 meters per second. I hope you are with me here. So dy by dt is minus 8 by 3 meters per second. So dx by dt is positive, which means that as the ladder slides dx by dt, x goes on increasing. So you see dx by dt as a positive number, whereas dy by dt is a negative number because y goes on decreasing. So that's why you end up with a negative answer for part A. Let's move to part 2 of this particular question. It's an extension of question 1. We've been asked to find at what rate the area of the triangle formed by the ladder wall and the floor is changing. So what we've been asked to find is dA by dt. So let me see if I can stick on to the same picture here. Now let me not do this. So we have dA by dt. We've been asked to find dA by dt, right? So area of the triangle formed by the ladder is half of, sorry about this, half of base height, which is x into y, which is nothing but, so dA by dt equals half into dx by dt times y plus half of dy by dt times x, right? So we've been asked to find, so folks, here we are. So we know following, we know dx by dt, we now know dy by dt, and we have been given points x and y, right? So dx by dt is, go back, 8, and dy by dt is, that we know dy by dt is minus 8 by 3, and x is, dx by dt is 5, and at the point x 8 and y equal to 15, right? So let's apply these numbers into the formula that we have. Dx by dt is 5 into x we have is 8, is 40 by 2, which is 20, minus dy by dt is minus 8 by 3 into x. So half into y, which is 15, into dx by dt, which is 5, minus half into 8 divided by 3, which is our dy by dt, into x, which is at 8, right? So we have 15 into 5, which is 75, divided by 2, minus 64 by 3, 64 by 6, right? Hey, let's do it this way. This is a lot easier, right? Let's remove out half, and then we have 75 minus 64 divided by 3, right? And so let's do this. We have half of, remove 3 to the numerator, 225 minus 64 divided by 3, right? So, which means we have 161, which is nothing but 225 minus 64 divided by 2 into 3, which is 6. So this is the rate at which the area changes, right? So here we go. And thank you all. I hope you had a good understanding of how Pythagorean theorem can be applied, and at the same time the application of differential calculus in this particular problem. Thank you. Stay tuned to my channel for more interesting problems in mathematics. Have a good day. Thank you.